All right, this is in Chapter 5 notes. We're going to finish this problem about the pregnancy. This is going to use z-scores, and I'll show how to calculate all the z-scores, to use normal CDF, and to use inverse norm when it's appropriate. So here's our situation. A woman is pregnant. She's due in 100 days. We know that babies don't always follow a strict timeline and time schedule on when they show up. So, and this is a biological measure. So the distribution for this, well, we're going to make up some data and have a theoretical distribution here. We're going to say that we have a mean of 100 days. So that would apply to pregnant women at this stage of their pregnancy, and a standard deviation of 8 days. So for this problem, our model is a mean of 100 days and a standard deviation of 8. So that's how we will structure our work. Suppose her husband has a business trip scheduled and he's going to return in 85 days. So what's the probability that the birth will occur before he comes home? So if we kind of put together a picture of what we're looking at here, remember in our normal curve here, you always want to measure the center, or you always want to label the center. In this case, we have a mean of 100 days, and you could label that X bar. And the standard deviation of 8, that would help us build the plus or minus standard deviations away. I'm not going to label the whole x-axis. That's not necessary. Only do that if you're asked to do that. What I would do is I would label what I need. So I want to find the probability that the baby will arrive in X number of days before 85 days. So if I just kind of eyeball this, I'm gonna put 85 right here. Now, if you want to think about standard deviations away from the mean, this would be 92, and then subtract 8 more, that'd be 84 right here. So this value that we're interested in right now is just over, or just under 2 standard deviations below the mean. All right, I'm going to move this label. We're interested in finding the probability that the X value that occurs here is less than 85 days. So there's my 85 right there. I'm interested in this part of the curve, this area to the left of 85. Okay, now this doesn't fall in a way that the empirical rule will help us. So our task is first to find the z-score. So the z-score, remember, here's the form for it, x minus x bar over standard deviation. Or if you're using population data, it would be x minus mu over sigma. Same thing. So in this case, our z-score is our point of interest, 85, minus the mean of 100, divided by the standard deviation of 8. So our numerator is negative 15, denominator is 8, and let's convert that to a decimal. We're going to use the table and the calculator, so we want a decimal at with 2 decimal places. So we can use the z-chart. So if we do 15 divided by 8, it comes out to negative 1.875, which is fine if you're using the calculator. If you're using the table, we're going to have to round that to negative 1.88. Now, another way you could use the table is you could look up the value at negative 1.87, look up the value of negative 1.88 z-score, and then take the middle of those two. For what we're doing, we're just going to use, we'll just round it and use that value. Okay. You should also not be surprised that it's a negative value because it is below the mean. So when you look at the z-score in the table of negative 1.88, you're on the negative side of the z-scores, go down to negative 1.8, and then go across the table until you get to 0.08, and that makes altogether negative 1.88, and I get an area of 0.0301. So that basically means that this is, usually I'll write it up here, that means that there is a approximately 3% chance that the birth will occur before the husband comes home from his scheduled business trip. Remember that the table gives us an area or a probability. Those are the same thing. The area represents the probability of something occurring. Now, normally I would write this out in a sentence, but let's check this out in from the calculator world. So normal CDF is what I want to use. Now I'm going to write this out as if, we're entering it from scratch. The first thing you enter is the lower boundary. Now on this lower boundary, I need just a number much lower than 100. I'm just going to use 0. Now you could use what comes up as the default in the calculator, which is -1 times 10 to the 99th power. You could use that. You could use, -1,000. That's plenty small enough. I think I'll just use that. -1,000. Now, we can't have negative days of pregnancy. It doesn't matter about what the context of the problem is here. Your calculator is trying to do the math. Okay, so that's the lower boundary. The upper boundary here is actually 85. Now we're putting in numeric values, data values here. The mean using data values is 100. The standard deviation using data values is 8. So we're going to put that in the calculator and see what that yields. So we'll use second distribution. Normal CDF is number 2. Hit enter. There's a lower boundary. We can change that to -1,000. You could also just leave it just like it is. Upper boundary is 85. The mean 100. Standard deviation 8. By the way, if you use a mean of 0 and a standard deviation of 1, you can actually find the z-scores, or use z-scores to do this same thing. So hit enter. That actually fills out this formula. Hit enter again, and there we have the calculator comes up with 0.0304, basically. That's virtually the same thing that we got. The reason for the differences, one reason is that we rounded. The Z table obviously doesn't use all the decimal places available, so it's an approximate number. Your calculator uses tons of decimal places, so, I guess technically you could say it's a more accurate answer. But you know what? Both of these are close enough, about 3%. So there's about, remember to use weasel words. There is an approximate 3% chance the birth will occur before the dad gets home. And usually with word problems like this, you want to write your answer in a complete sentence. And you want some context, and you want to be accurate, concise, and with context. Okay, so that's one problem. So let's say the husband has another business trip planned in 107 days. What's the probability that the birth will occur before the second business trip? So again, we have 100. We have 107 sitting out here. One standard deviation is 8. So if I want to think about where that is, that would be right here, about 108. So we're just less than one standard deviation above the mean. And we want to know the probability that the birth will occur before the second business trip occurs. So the probability before 107 days. Now, we're basically saying, we hope that that baby is born before dad has to leave again. We're not going to worry about his first business trip right now. We're just going to worry about the second one. So we need a z-score for this. We have 107 days minus the mean of 100 divided by the standard deviation of 8. This, you shouldn't be surprised to have a positive z-score, a positive numerator, because it's above the mean. And this z-score comes out to be 0.875. And we're going to round that to 0.88. Using the table on the positive side of the table. And we also know here that this definitely has to be a percentage bigger than 50%. So the positive side of the table has all areas bigger than 50%. If we look up 0.88, we have to start with 0.8 and then move over to the right to the 0.08 column, and I see, and hopefully you do too, that the area or the probability is 0.8106. Okay, so approximately 81% chance that the birth will occur before the second business trip. let's do that real quick on our calculator. We're going to do normal CDF. And we're going to plug in the lower boundary again. A very small number, like extremely small in the context of the problem. The upper boundary now is going to be 107. The mean is a 100 and the standard deviation is 8. We'll see what that cranks out. Another way to do this on your calculator, you could just arrow up, go grab that initial function that you had, normal CDF, because we only need to change one number. Instead of going up to 85, we're going to go up to 107. So 10, now it's a different length, so I have to insert that third digit, 107. And there you go. I can just enter that. So 80.92%. Okay, so we got 80.8092. Now that is still pretty close here. And like, you know, if you rounded to 2 decimal places to talk about a percent, both of these would be 81%. You know, and the difference that we're seeing there is because of this rounding issue. So the probability or the chance the baby is born before the second trip, the second business trip, is approximately, I'm going to abbreviate, 81%. Okay? So the classic next question is, what's the probability the husband's going to be there for the birth, given that he has to go to both business trips? So we had 85 as the lower end cutoff, like he's going to be gone before that. And then 107 was the cutoff at the top end. So we want to know, this is the time, this represents the time period that the dad is around. And so we want to know that probability. So we already have these numbers to help us. Like if we look to the left of 85 was 0.0304. I'm using the calculator numbers. And then to the left of 107 was 0.8092. And I want to know the difference between those two things. So the probability that the baby will be born between 85 days and 107 days is actually going to be equal to this bigger probability from 107, and I need to subtract out the smaller probability to the left of 85, and that will give me my result. So the difference here is 7788. So there's a 77, approximately 77.9% chance the dad will see the birth, or will be in town for the birth. Now these numbers that I used here were calculator numbers, right? So they would be slightly different if you were using values from the z-table and z-scores. Okay, you could do the same thing. You're going to get something similar. Either way will work. Sometimes you might be asked to use strictly z-scores. Other times you could use, you know, these numeric values that are all going to be close. Okay, so I'm going to stop this video here. And there is a very intriguing next step that I'm going to put in a separate video.